Hey guys, I welcome you all to the live session on DevOps by Intellipaat. This session is conducted by an expert having more than 10 years of industry experience. Before we begin the session, make sure to hit the subscribe button and also hit on the bell icon so that you will never miss an update from us. On saying that, let's see the agenda of the day. Firstly, we will begin with introduction to software development. After that, we will introduce you to DevOps and its lifecycle. Then later on, we will learn about different models like Waterfall Model, Agile Model, Lean Model, and also comparison between these models. Then later on, we will see how DevOps work and what are the top DevOps tools available. So, this is the agenda of the video. Without any further delay, let's get started.
What is software development? So guys, software development is basically the process of transforming customer requirements into a complete software product. Right now, what that means is, let's say I have a set of requirements that are given to me by a customer. That let's say this guy is running a music company, and what he wants is that all his students should be able to mark their attendance on a particular app. This is his requirement. He comes to me as a software company and tells me that, you know what, I need an app where my students can basically mark their attendance. So can you go ahead and please tell me, like, how will you go ahead and what kind of features will you add to my app? So this is basically the stage wherein the customer gives the company the requirement. The technical architect of the company will understand this software requirement, and then he will tell the customer that this is the plan, this is what, or this is the kind of app that we are basically going to create for you, right? So this, from here on, whatever process is going to be followed, that is from a piece of paper with a set of requirements are written to a complete software product which is handed over to the customer. This whole process is basically referred to as software development. Now, to understand how basically the software is made, or to understand what this process basically comprises of, there are basically 5 stages in software development. The first stage is requirements. So herein, what you do is you basically gather all the requirements from the customer. Basically, the technical architect gathers all the requirements from the customer, and then basically these requirements are converted into a technical document, which is then forwarded to the developers. So this technical requirement, when it is written, it is basically called the design stage. Now, once the design stage is over, right? So once you basically have decided the technical document, the next step that you would be doing is you will be basically going ahead and giving it to your team for implementation, right? So this technical document is now given to the team of developers, and these developers now basically go ahead and they start working on the requirements which basically the technical architect has told. Now, once this happens, the next step is basically the verification stage, wherein what happens is the testing happens for the product, right? The testing of the product starts. Each and every component of the software is tested, and when it is combined, again it is tested, and finally it is released to the customer. Now, once it is released to the customer, the next stage or the next step which happens is basically the maintenance phase. And here in this phase, what happens is that the bugs are reported by the customers, and new feature requests are given by the customers, and those feature requests or those bugs are fixed. So this you can compare usually to either the OS updates that you get on your mobile, or let's say if you're using Windows, you frequently get Windows 10 updates, right? So all these updates are basically a part of the maintenance cycle which is happening for the product that you're using. If you're using a mobile device, that the software maintenance phase is happening, and the updates that you get are basically feature requests or bug fixes, which are basically done by the development team and are rolled out to you, right? So in short, this is basically the software development lifecycle which basically happens. Now, moving forward, the requirement stage. In the requirement stage, what happens is the requirements are basically taken in, and it is understood by the technical architect, and basically then the requirements are then carry forwarded, and a technical document is created. Once a technical document is created, the next step, what happens is the implementation starts, wherein the developers, they start working on the design, which basically the architect has put forward. After that, the tests are basically conducted, and finally the maintenance stage happens. So this is what we just discussed. Now, after this, once this process has been identified, now you will understand, okay, so software development is very easy. All you do is basically you go ahead and you follow this step by step, and the output of this process is a software that you are looking out for, right? But it is not that easy, actually, especially when you have to get it done with the team, right? Especially when you have so much different kinds of product requirements from customers. So that's why we have different methodologies or different ways of following this particular process, which is the SDLC, or the software development lifecycle, that we just discussed, right? The first way of following this SDLC is called the Waterfall Model. The second way of handling this SDLC is called the Agile Model. And the third way of handling this is called the Lean Model. Now, what is the difference between these three? Let's go ahead and understand. So talking about the Waterfall Model, guys, in Waterfall Model, what happens is this same SDLC is basically treated as a waterfall, as if something is flowing in one direction. Now, one direction over here is the keyword, that whatever happens, it just happens unidirectionally. That means if, let's say, the requirements are taken in, and if the requirements are set once, and once you, let's say, reach the design stage, after you reach the design stage, you can never go back to the requirement stage saying the customer has come back again and he wishes to add one more feature. No, that is not at all possible once you have locked one stage of the software development process. This was called the Waterfall Model, and this was done because obviously, if you have a customer who is confused in what product he wants, and he's always bugging the developers with respect to the new changes that he wants, it obviously, if there are new changes which are basically told in a particular product or a software, it might be that they have to go back to the whiteboard and design everything again and then start from scratch. So to avoid all those things, when Waterfall Model was basically decided that this is what we want to follow, right? So basically a flow was decided that once we are done with the stage, we are never looking back, and we are never going to go back to the scratch board and understand that this, how the new requirement of the customer can be put in. All right. Similarly, once the design stage is over and the development has started, if the designer thinks that, okay, let me change this particular thing in the design, and I think this will make the software better, even that is not allowed. So once the designer's work is over, there is no going back to the design stage again once the development has started, because that will not only account for delay in delivering the software, but that also means wastage of time, because there are always better things or better ways to do a certain thing. So once you have completely decided, take your time, and once you have completely decided that this is what we want to basically execute, you will only do that, and you will never go back to the previous stage or to the whiteboard to scratch things out. Okay, so that's what the Waterfall Model is, guys. Now, then came a new method as the customer behavior changed, and that's basically called the Agile methodology. So Waterfall Model worked pretty well for very complex softwares, right? But the problem with Waterfall Model was that, first of all, obviously, the biggest problem was the customer. If, let's say, he comes up with a new requirement that cannot be accommodated once a development work has started. So that was problem number one. Problem number two was that whole life cycle took a lot of time for the software to be delivered, right? So let's say if I am opening an e-learning company like Intellipaat today, right? And if I want an LMS system which has to be designed, and if I approach a company who's basically following a waterfall model, they will probably give me a 6 months time, that in 6 months you will get the software, and then you can see you can implement it, and then you can basically understand how it works. But my requirement is, I want to start my company today. So what is the fastest way possible that you can basically send that product out to me? So that's the era that we are living in right now, right? So whatever basically work is given to any of the companies these days, whether they be competitors amongst each other as well, the work is always given to a company which can deliver the results faster and in the most quality manner possible. So to do that, there was a new methodology that we had to come up, which was basically agile methodology. And agile, basically, as the name suggests, is a lot more flexible in terms of working. So what does the agile methodology says? Agile methodology says that, let's say there are 15 or 20 features that we have to develop in a software. We are not going to design each and every requirement of the software right now. We are only going to design the bare minimum requirements, and then we are going to start off the work. Now, how is this helpful? This is helpful because with the agile development, not only you can give out the software faster. Let's say I, as an e-learning company, I tell my whole product idea to the company who is developing my software. So the company says, okay, you know what? I understand that you need a very beautiful UI, but what I can give you is, in the next 1 month, I can give you a UI which is workable.
Just a quick info, guys. Test your knowledge of DevOps by answering this question. What does DevOps stands for? A. Development and operations. B. Drive and operations. C. Digital and operations. D. None of these. Comment your answers in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
A UI which which probably your customers can come on, they can pay you, and they can start learning. Whatever beautification that you have to do in the UI, whatever extra features you want to do in the UI, I'll probably do it in the next release. But this is the fastest, and this is the product that I can give you right now in the next 1 month, using which you can not only earn money, but at the same time, if you, let's say tomorrow you want to do any change in the UI, you can tell me after 1 month, and anyways I'm going to start with the UI release of yours, or the UI part of the beautification part next month on your products, and you can tell me if your requirements change. I can accommodate that, and I can give you out the product. Right? So that's what agile methodology was. Not only this accommodated customer requirement change, because let's say if today I need an app which is basically going to be for Android, and you tell me, okay, so this app is going to take around 6 months to create, and tomorrow Apple launches an iPhone which is very affordable, right? So that means that 50% of my customer base, let's say, has now shifted from Android to iOS. So I need my app to be on the iOS platform as well, or I need my app to be on the Apple platform as well, right? So I cannot change my requirements or wait for 6 months and then I'll give my requirements to the company. I want it to be done as soon as possible, right? So if that is the scenario, we obviously need a methodology which can accommodate changes, and this is exactly that methodology that people basically prefer now, not only because the changes can be accommodated, but also at the same time, a workable product is delivered very soon. You do not have to wait for a longer time in order to get your product. That's what the agile methodology is. Then comes the lean methodology, guys. Now, as you saw that in waterfall methodology, there was a unidirectional kind of a flow, which was basically followed. In agile methodology, you basically saw that, okay, you could go back and forth with respect to the requirements, because over here, things are a lot more flexible. You basically do small amounts or small parts of the app one at a time, right? Now, there was still a problem wherein, we thought, okay, so agile methodology is a lot much faster than what waterfall model was. But I think we can still, improve the amount of time that we are taking to basically develop the product. And that, for that sole reason, we basically came up with lean methodology, in basically which we basically told that in lean methodology, not only we are going to follow the agile methodology for our work, but we are also going to focus on, reducing the waste time that we basically are spending on things which are not required. For example, if you are doing 3 scrums in a day to understand what the progress of the work is, probably you can reduce that to 1. You can do a stand-up meeting in the morning. You can discuss what features you will be finishing at the end of the day. And you can do 1 meeting probably in the end, just to tick off topics of what you have completed as to what you had planned in the morning, right? So basically the lean methodology tells you that follow the agile methodology, but also think about how you can save time. So all the things which can save time you are basically going to use in your team. For example, you can hire people who are more skilled in what they do rather than people who are new to the work that they are doing. Not only this will increase the quality of the work, but this will also reduce time in research and development which has to go. So if there is a person who already knows how to design an e-learning product versus a guy who has never worked on an e-learning product, it's always a good way out to basically hire that guy who has the e-learning experience and can develop the e-learning app for you, right? So that's what this methodology drives. This methodology drives decisions like these, which will basically help you to reduce the amount of time which is spent out in a project. Okay, so carving out the differences between the three methodologies that we discuss a waterfall methodology in which this star is basically customer feedback. So the customer feedback and the release of the product always used to happen at the end of the life cycle.
Just a quick info, guys. Intellipaat provides DevOps online training validated and certified by NASSCOM Future Skills and IBM. The course link is given in the description below. Now, let's continue with the session.
It always used to happen in the last when the whole software product was developed, right? Versus when you were following the agile methodology, not only you were getting the feedback 3 times in the same amount of time that you were spending in the waterfall model, but also you were basically delivering the software in 1/3 of the time that you were delivering in waterfall model. Obviously, you were not delivering the full workable product, but you were delivering the bare bones of the product using which the company can actually start earning business. And with the passage of time, you were basically adding upon new features which they could add in their product and which was basically closely resemble what they actually expected, right? And because of this customer feedback which is happening a lot more times now, even the new accommodable changes which had to happen, which probably the customer thought we could do better, right, is also being accommodated. So not only a customer is happy who wanted the software to be developed, but also at the same time that software itself was developed a lot faster. Okay, and in the third model, lean methodology, you followed the exact same things which are there in agile, but the also one thing that you basically focused on was eliminating the extra time that you were probably investing in your project. Could be because of the resources which are already there in the team, or could be because of the multiple meetings that sometimes go unproductive. Okay, so this was the 3 methodologies which were there in the software development lifecycle, and because of these, there was a requirement for DevOps. How? Let's go ahead and understand. So the problem between customers and the software company which existed when we were following the waterfall model was solved when you were using the agile and lean methodologies, right? Because now the customers were not only getting their software a lot faster, but at the same time, they were happy to give changes that which they could not think of when the product actually started building, right? So this particular problem was solved. But why did we need DevOps when this problem was solved? Because this looks like a happy story. Everyone is happy, the customer is happy, the company is happy. So why are we needing a new methodology in place to basically, erupt the whole world and start off learning new things? So that happened because there were still problems within the company which were to be sorted out. For example, if you have ever been a part of a tech team, there are usually clashes between the operations team and the developer team. So the operations team are the guys who basically take a product and deploy it on the production or the testing server, or the operation team also comprises of testers. So these are the people who are always in a, they are always closely associated with developers with respect to the work. So one team is basically the QA team and the other team is the team which is basically developing the product. Now, obviously, the QAs are the people who find out bugs or who find out mistakes in the product, and that's why the relationship has never been that good. Now, because of this fight or this back and forth which used to happen between the developer team and the operations team, there was a lot of time which was getting wasted, right? And the intent of implementing or introducing methodologies like agile and lean was that we basically wanted the customer to be very happy. We wanted the customer to have the best experience possible. But because of these problems within the company, right, between the teams itself, the end result was not that great. And hence we needed a process over here which could solve these problems which were happening between the developers and the operations guys. So what were the different kind of problems that these guys were facing? Let's discuss that. So a developer is a guy who basically develops the product, and like I said, operations team is basically the team which is basically probably going to do the QA of the product, or they're going to deploy the product at the place that the developer team wants, right? Now, what used to happen was the developer used to, create the feature that he was assigned, and he used to tell the operations guy that, what, I've created this feature. Can you check it or test it on your system and let me know whether it's working or not, right? So, but when the operations guys, they basically used to run the code on some other system other than the developers, the code did not used to work, and it could be because of many reasons, such as probably the software which this code wants is not installed on the operation team's system, or the software which was earlier used in running the product. A latest version of that software is supposed to be updated in the operation team's system. And because that is not happening properly, there is an error which is happening. It could be because of dependencies which the code has. It could be because of anything.
Just a quick info, guys. Test your knowledge of DevOps by answering this question. Which of the following is a DevOps tool? A. Git, B. Jenkins, C. Docker, D. All of the above. Comment down your answers in the comment section below. Whoever gets the correct answer will win 5,000 points in Intellipaat wallet. Subscribe to Intellipaat to know the winners. Now, let's continue with the session.
Right? But at the end of the day, even if the code is correct and the operations guy is not able to run the code, the operations guy used to send the code back to the developer saying the code is faulty and you should check what is wrong with your code, because this is not running on my system. And if it is not running on my system, I cannot pass it on to the main server or to the production system to make it work. Right now, because of this, there was a problem between the two teams, because the developer said, I've done my job, I've done with the feature, I'm not going to go ahead and babysit this operations guy's system and understand what exactly the problem is and why it is not working over there. And the operations guy used to say, I'm doing my work, I'm not here to debug what is wrong with your code. You go ahead and fix everything that you want and give to me a product that I can actually run and test. Right? And because of these sentiments, there was very much a back and forth between the team. And to solve this, we basically had to come up with a process which is basically called DevOps. Okay, so DevOps is a process which basically solved this particular problem between the developer team and the operations team. And this is what we are going to discuss now. This is the story so far. So by now you should now understand how DevOps is basically associated to the tech world. You should understand what it solves, and you should understand why it was invented. What it is exactly we are going to discuss in a moment. Let's go ahead and move further. What is DevOps? So guys, DevOps is basically a methodology which we just discussed is going to solve the problem between the developer team and the operations team. And how it does that is basically using the diagram that you see on the screen. So this is an infinity diagram, which basically says that the first stage that you start out with is plan. So you plan the code, then you basically develop it, then you build it, then you test it, then you release it, then you deploy it, then you operate it, and then you monitor it. Now you will say it resembles the software development lifecycle. What is new over here? Well, the new thing over here are two things. First thing is, the moment the code reaches the maintenance stage or the monitor stage, it again comes back to planning, coding, building. Right? Why? Because once it comes in the maintenance stage, the bugs will be reported, and again the bugs will now start fixing by reaching the plan stage, wherein the bugs are planned on how to basically be fixed. Then it is again given to the development team in the code stage. Then again there is the build stage, then there is the test stage. So you will say, okay, So I understand the infinity sign means that once the release or the development of the code is over, again you basically start developing the code by looking at the changes that the customer is saying, and again you start working. So that is understandable. But how is this fixing the problems between the development team and the operations team? This should be a question. And the answer to that is, guys, every stage in this happens automatically. There is no human involvement over here, right? So when you plan the code or when you plan out the software, the architect basically puts this plan out on a software which is automatically distributed among the team members with respect to their work. So whatever features are planned, each feature is assigned to probably a group of 2 or 3 developers, and then they start working on it. When the coding is done, when the feature is done by a developer, he basically puts his code on GitHub or a version control system for that matter, and it automatically, the code gets picked up from there. It starts getting built on automatically, an executable is created automatically, it is deployed on the testing server automatically, it is tested automatically. If the test gives out a problem, it is emailed to the developer, right? And if it goes successful, again the feedback is also given to the developer that the test was successful, and hence the feature goes forward, and automatically it is deployed on the production server as well. So in this, you will now say, okay, so if this is all automatic, does that mean the ops team is not at all there? No. In making this automatic, for example, if a product has to be tested, and if it has to be tested automatically, what you will do is you will need a set of automated test suites. And this automated test suites will be basically created by the testing team, right? And then these will be uploaded as part of the DevOps lifecycle. And as and when new code will be uploaded by the developers, automatically a bunch of DevOps tools are going to pick them up, make them do go through the testing or the automated test cases which the testers have created. And if there is any error which comes in the test cases, those errors are automatically mailed to the developer directly on his email, right? He gets the email that these are the set of things that are giving you an error, and the developer now does not have to interact with anyone, right? If let's say he is working late night and he's committing his code at 3 a.m. in the night, right? And he wants to get the feedback immediately, he will get the feedback immediately. He doesn't have to wait for the tester to log in and give him the feedback. Second of all, since everything is automated, if the developer says that this code will probably run on Python 3 and not on Python 2, if this is mentioned along with the code, this can also be automated that on whatever server this particular code is being tested, the automation server ensures that that particular target system has Python 3 installed instead of Python 2. This is also possible using DevOps tools, and this is basically something which is called as configuration management, right? If let's say the code has been released onto the production server after being successfully tested, all the feedbacks which have to come to the customer, they also come automatically, using probably software tools that you have developed. For example, whenever you encounter an error, let's say in Windows, you always get that option of send error report. What is that send error report? That send error report is basically a method of you telling the developers who are sitting in the company that this is the error that I got on my system and my system crashed. Look at this error and fix it in the future releases. That's what that send error report means. You would have also seen on your mobiles when you basically are setting up an account, send usage related statistic details to the company. What does that mean? That also means that whatever work you're doing on your phone or your system, if there is any error which occurs, that error will directly be sent to the company. And these are all collected as part of our automated monitoring tool which is then basically made available to the technical architects or the managers, that these are the errors which have been reported worldwide when your product was being used. And these are the things that you have to fix. So this is again planned. This is basically again given to the developers fix it, and again it is released. And then you see that in your phones, you see that this particular OS update is having these particular features which are new. These are the bug fixes which are there. So that is the change log that you get, right? So all in all, you would have experienced, or you were a part of a DevOps pipeline or a DevOps methodology and you never knew, but it is happening all around us, right? And this is exactly what companies are implementing these days. DevOps is being implemented in every company which deals with softwares, because not only it basically is reducing the human factor involved in making a software product successful, but also at the same time it is also reducing a lot of time which is invested in creating a product, whether it be because of back and forth that the time is increased, or because of the coordination between the two teams, that is the development team and the testing team, whatever the reason may be. But when you make the whole process automatic, it saves a lot of time and it saves a lot of back and forth as well. So giving you a brief of what the DevOps pipeline is all about, or the life cycle is all about, like I said, you first plan and code, and then you basically, once the code has been submitted to GitHub, it automatically gets pulled up and it gets built, it gets tested. If that is successful, it is released with the configuration management changes, whatever software changes are supposed to be done on the target system, and then you basically deploy, operate, and monitor it. This is what the DevOps lifecycle is all about. And the main thing to learn over here, or what you will learn in this course, is how to create this automated lifecycle using various tools. So there are more than 9 tools that we will be discussing as part of this training, which will help you implement or create a lifecycle like this, right? So some people ask, does this require coding? Not at all. These tools does not require any coding. What they do require are some commands that you will have to learn. What they do require are certain methodologies that you will have to learn. And that's what will help you in creating this kind of a life cycle. So how does a DevOps life cycle look like in a daily in a daily company, or in any general company? It looks something like this. So this is a developer who's working as part of a DevOps lifecycle. This guy, he basically puts out the code that he was supposed to develop on a platform like GitHub, which is basically version control system, right? Whenever a new code is pushed to this version control system, this automatically gets deducted by something called as a continuous integration server. Now, this continuous integration server automatically picks up the code from the version control system whenever anything new arrives over there, and it pushes it down to the testing server. And the testing server already has the automated test cases which have to be run against the code. These test cases, if they are successful, the feedback is given to the developer and the continuous integration tool that, what, the test is successful. And if it is basically pushed out to the production server. If it is not, then the feedback is given to the developer, and he again has to go through this life cycle, right? If the product gets released on the production server, again, there are error reports which the users will send. And these error reports are again part of the feedback life cycle, or the continuous monitoring life cycle, which is again fed to the developers, and the developers fix it. And again, the codes go through this life cycle. This goes on and on. It never ends. And this is exactly what the infinity sign in DevOps means, right? So guys, this is how DevOps basically work. Let's move forward. So what are the DevOps tools that basically help us enable this DevOps lifecycle? So there'll be a lot of tools, guys. The first tool in continuous develop is Git and GitHub. That is what we will use to version control our code. For continuous integration, we will be learning Jenkins in the course. So Jenkins is the heart of the DevOps pipeline, which will help you integrate all the tools together that you're going to use. For continuous deployment, we are basically for configuration management and continuous deployment, we are basically going to make use of Ansible and Puppet. And for the other things in continuous deployment, such as containers, etc., we will be making use of Docker. For continuous testing, we will be understanding how Selenium basically works. And for continuous monitoring, we will be understanding the Nagios tool. There is one more thing, which is infrastructure as a code. Let's say if you want to deploy a set of servers on the cloud, for that, we will be teaching you Terraform as part of the training content as well, right? So just to replace all the things in the initial diagram that we saw, so the developer is going to push his code to GitHub, which will automatically be detected by Jenkins as a CI tool, which will be deployed on multiple servers using configuration management such as Puppet and Ansible. And with Puppet and Ansible, in case containerization is required, Docker will be used. On the testing server for automated test cases, we will be making use of Selenium. And if everything works out well over here, we will be deploying it on production server, wherein the feedback, if anything comes, will be monitored by Nagios. Okay, so guys, this is how the pipeline will look like when you replace it with the tools that we're going to learn in this course.
Just a quick info, guys. Intellipaat provides DevOps online training validated and certified by NASSCOM Future Skills and IBM. The course link is given in the description below. So guys, we have come to the end of the session. If you have any doubts, please put down in the comment section below. We will try to answer it as soon as possible. Hope you all enjoyed the session. Thanks for watching.